Hello guys and welcome to this quick 1 hour video. It's not very quick, but 1 hour, right? To create this snake game. Okay, basically it's the very classic game that you use a snake to eat fruit and you grow longer. Right, there's a score keeper on the top center of the UI. And it's basically try to stay alive and eat as much fruit as possible to get a higher score. Now when you, of course, when you hit the wall or when you hit the tail, you will be dead, right? So when let's hit the tail here, right? You can see now I'm hitting the tail. Game over. We can either quit or restart. Okay. Yeah, and it's just that simple. You can click on the quit to quit the game. Yeah, let's go ahead and do it. So we start with the game here in Unreal, of course, and blank. Next, blueprint, maximum quality, ray tracing, all those default settings basically. Right, we can call this guy greed snake. And then create project. Now we have all played the snake game, right? You have a snake that goes around, eat fruits. Whenever it eats that fruit, it gets bigger, gets longer, right? But when it hits the wall or hit itself, it's going to cause the snake to die, right? Or you lose the game basically. So let's go ahead and do that. Okay, first thing first, I need to go ahead and create our player control, right? So I'm going to right click here and create or click it there and add new blueprint class, and we can choose pawn as the class, right? Okay, I'm going to call this guy BP snake head. Double click to open it. Okay, so this is our snake head, and we're able to control its movement here. So I need to give it a static mesh, right? I think a sphere will actually be fine. So I'm gonna call this guy head, compile and save that. For the head, we wanted to be able to collide with, not collide, but overlapping with other things. So I'm gonna go change the collision here to generate overlapping events, and then collision precise will be overlap all. That way it's gonna be overlapping anything, right? That way it's easier to detect anything that's overlapping. In the event graph, we just need to be able to control its location, right, by using various button commands. So I'm gonna go to the edit project settings. Okay, and then I'm gonna go to inputs, and then binding. I'm gonna click on the action mapping 4 times. This is gonna be move up, right, and this is gonna be move down, move left, and then move right. Up will be W, down will be S, move left will be A, and then move right will be D. Right? So now I can use those inputs here in the blueprint event graph. Okay, so I can right click and say move up. Okay, and then for move up, I need to define a up direction or the direction, right? So let me create a variable for the direction of the snake head. So a new variable, and it's going to be of the type f vector, or actor actually. That's f vector is actually the actual type underneath. So the variable name is called move direction. Okay, so move direction will be changing. It will be 0 in the default settings, but when I say move up, the move direction, oops, not setting it, not getting it. I can holding down Alt and drag move direction out to get a set node for that. I'm going to set it to going upwards, which is the X direction. The reason for that is because when I drag above here, and if I look at top down here, up is X, right? Right is Y. So yeah, I'm going to do move down here. Now move down will also, I'm selecting that and press Ctrl W to have a copy of that. Now pressed for move down will cause the move direction to go to -X. Okay, and then we can do move right. Move right will be changing the move direction to positive Y, and then move left will be changing the move direction to -1. Right. Of course, this will not do anything. It's only changing the variable. So in the event tick, that's when I wanted to actually change it, right? So on event tick, I'm gonna say add actor world offset to offset the actor. The delta location will be the move direction. And then I also wanted to define how much I want to move on every step. And that's going to be determined by the size of the model. So an easier thing to do is I can just get that size of the model in the begin play. Let me drag the head out and get static mesh. And then I'm going to get how big it is, get bounds maybe. Okay, let me split that. Well, that doesn't help actually. Let me just get bounding box, because I just need to know how big it is using the bounding box, right? Easy and cheap approach. Split that. You can see I have the value mean and max. I'm going to split that and that, and I'm using x, max x minus max min x. And this will give me the size on the x dimension, but I'm doing a sphere, so it should be fine, right? And that will be promoted to a variable here, right? And the variable will be step size. Okay, and here I'm gonna multiply move direction with my step size. You can drag it over to here. The result goes to the delta location. Compile and save this. Now I don't want it to be moving in a smooth way, because the real Snake, if you ever played that in old school one, right, it's jumping, right, step by step. So our tick interval will not be 0, which means as fast as possible, I think, or as fast as the how your game ticks. So I'm gonna change that to 0.25. So it's gonna tick every 0.25 second. Compile and save that. Okay. Now to be able to use this guy, the easiest approach is go here. We can change our auto possess by auto receive input to player 0, right for our sphere here. We also need a camera here. I'm gonna drag in a camera. Yeah, drag it in a camera and drag it up. Make the camera look down, -90, and drag it up. Something like that. Okay. And then I can go here and say auto, should be somewhere we can set it to be the player auto activate for player 0. So when we play the game, the player will automatically possess that, not possessing, but taking that camera as the view point, because this guy, the actual pawn, is not really having a camera in this case. Okay, let's go ahead and play this. You can see I can hit up, down, left, and right to move it. Or you know what? I'm not moving the pawn. Sorry, I'm probably moving the actual pawn there. This again, not receiving input. Sorry. Now there, auto possessed by player 0. Okay, play this. Now you can see when I hit up, down, left, and right, I'm moving the ball. Right. It's popping a little bit. I'm gonna go to the project settings and turn off the motion blur. That's probably why it's doing that. To check that out. Now it looks better. Right. It does have a little bug though. If I turn left and then I hit right, or right and then I hit left, you can see I can go directly backwards. Right. So that's not good. I need to know where I'm going and prevent it from doing that. Right. So one of the things I can do is to, for every tick here, right, I need to, before I move it, right, I can get actor location, Okay, and then I can get I can then promote that to a variable. Okay, I can call this guy actor pre-move location. And that's where I was, pre-move location, right? And then here when we're moving here every time, I need to know that pre-move location, and I need to know if the new move direction will actually make it just go backwards, right? So I need to know how much it has moved. Oh, yeah, I have to actually do the calculation in here. Okay, now do the move, right? And then I'm gonna get actor location here. Okay, and then I'm gonna minus that vector minus vector, and minus that pre-move location, right? And then I'm gonna create a new variable or promote that. And this will be called current move direction. And that's gonna give me what is my current move direction by subtracting the locations differences after and before. I can speculate, you know, where I'm moving in this case, and that will be the judgment for should I be able to move, right? If my current move direction, right, I can split that. If its direction x is not equals, if it's equals to not equals to 0, I know that I'm not moving, I'm moving on x, so I should be comparing to equals to 0, right? I need to make sure that I'm not, I have to be equal to 0 on the x direction to be able to move on the x direction, right? Let me holding down B and click to create a branch, and that goes to there, and that goes to there, right? Now this criteria will be applied also. I'm pressing Ctrl W to duplicate that. It will be applied also to the down. Okay, for the other two, I'm going to duplicate the same criteria, but it's going to be applied based on y. So y has to equal to 0, so I'm not moving on y to be able to move on y-axis, if that makes sense, right? Now you could argue that we can use the direction, but you could quickly press the direction twice to flip-flop the direction to cause it to also move backwards. So the best way to achieve this is to actually calculate the last time, right, how we're moving it to prevent it from happening again, right? So let's try this again. You can see I can never go back unless I have turned in other directions, right? So it's never able to come back to before in this case, because we're calculating that in real time and see if I'm running in the wrong direction in this case. Whoops. Right, so that's the control. It takes some details checking, but this is something we call error handling, right? This is some bug we discover when we're developing, and we'll have to deal with it. Okay, again, if you use the direction to check, it's not gonna work because you can quickly flip-flop the values. Okay, alrighty, I'm gonna compile and save that. Now with this thing moving, I can then start creating the fruit and the tail. I'm gonna create a base class for those two things. I'm gonna right click here and say blueprint class. Okay, and then I'm gonna choose actor, and I call this guy triggerable. Okay, in triggerable, I'm gonna go to add a component and a static mesh component. I'm gonna call this guy mesh. For the mesh, I'm gonna change it to maybe a cone or something. I can define it later on actually. Let me define it later on. I don't really need to be, you know, something to experiment with. I think I have something would be better. Box maybe. Right. I guess I can delete that mesh and add the box right away, add a cube. Yeah, that's easier. And call it mesh. I can change it later on, right? This is just using one of the cube mesh. It's easier to find it. Okay, in the event graph, I'm gonna go scroll down to the mesh. Of course, I want it to be overlapping, so this is gonna be the same as the snake head. It's gonna overlap all and generate overlapping event. Scroll down here, I'm gonna say on component begin overlap. Okay, and drag it over there, maybe. And then I'm gonna check if the other actor is equal to get player pawn. Right, if the other actor is the player pawn, right, we can do a branch. Then I also want to just cast it to snake head, just to make things easier. I can just cast it right away. And then I'm gonna call another function, another event, right click and say custom event pawn overlapped or player overlapped. Okay, and then that's gonna take one input, which is of the type snake head object reference, and call this player. And then I'm gonna call player overlapped in here. Probably need to compile that and then recall it because we haven't really updated the name yet. And that goes to the player. That way, I'm not going to implement it here. This is going to be the base class, the virtual class. All it takes care of is to overlap with the player only, check the conditions. If it's true, then we cast it for us so that whatever child class that uses it will already have the player here. Okay, I'm going to right click here and then say create child blueprint class. I'm going to call this guy fruit. Okay, double click to open the fruit. Now we can probably make the fruit also a square, maybe. Yeah. Okay, so in the fruit, I can just go to the function overrides and override its player overlapped. It's underneath triggerable, right? Compile and save that. So you can see when the player overlap with us, we can already do something with it, right? So we can maybe just do print to test it. Hello, right? Go ahead and drag in a new fruit, play. You can see now we got hello printed. Okay, on the upper right corner of the UI if you didn't see it. Okay, so now I can go to the fruit. I'm of course not gonna do printing string, right? I want to give it score, right? So that means I need to have a UI for that. So I'm gonna right click and create user interface. Come on. User interface, and then go to the very bottom, you see widget blueprint. Just can't really show it. In here, widget blueprint. Went too far. This is gonna be my WBP main, right? Double click to open that. I'm gonna drag the text in here, holding down Control Shift and click on the anchor and click on the top center one to anchor it in there. Sets to content will be turned on, Y will be -1 to make it 1 unit away from the top, 1 size away, right? And the text will be score column and then 0 to start with. Font can be something bigger. I'm gonna change that to 30. Okay, compile and save that. I'm gonna check that to be a variable so I can access it in the graph. So I'm gonna go to the graph. Oh, let me also rename this. So I'm gonna grab that. Oh, I cannot rename it there. I'll go back to the designer. I'm gonna rename it to score text. Okay, compile and save this back here to the graph now. I can then grab the score text out and get it. Okay, I'm gonna go create another custom event and call it add or set score. Okay, and then I'm gonna go to the inputs and take a integer input, which is the number, right? I can call it score or new score maybe. Right, And then I'm gonna go to the score text and say set text to set the text in there, and then right click here. I'm gonna go create a string, append string. So this is gonna append strings for me, and the first A will be score, and the new score will be the second one. That way I'm basically composing right, score and then the score count, and that goes to the text. So that's gonna be in synchronized with the way I typed in the first place, which is like this, right? Okay. Now, of course, back here to our snake head. In the begin play, I'm gonna keep on going after this. I'm gonna go create widget. The widget will be our main UI, of course. Right, the only player will be us, right? So get player controller, the player, right? That's gonna be the only player. And then we can then promote it to variable so we can access it. And call this guy UI, main UI maybe. Alright, and then we can then add it to viewport. That way it's going to be in the viewport. So now when we play the game, you can see it's now on top of the viewport, right? And then when we overlap with the fruit, we can call a function here. We can implement right away, custom event, and we can call this guy add score. Of course, this wouldn't do anything other than just maybe add a new variable, call it score, not source, score. And that's going to be of the type integer also. When we add score, we'll basically drag the score here and get it, and then say increment. Right, you can see what it does is add 1 to the specific value and then set it. So the score will be changed to score plus 1. Right, and then the result will be, then we're gonna get the UI here, right, and then we can call set score, not set score. Okay, right, and that's gonna be our score here. You can double click on the lines to create rerun node, so that you're not collapsing, crossing the lines with the nodes. Right, so that way when we call add score, the UI will be adding 1 to the score. Excuse me. So now we can go back here to the fruit, and then we can just call add score function on the player. Go ahead and play the game. You can see now we're adding score when we overlap. Of course, that's not the only thing we want to happen. When we do that, we also wanted to, give the snake one more tail, right? It's getting longer, right? We need to do that. So let me go ahead and create a snake tail. I'm gonna right click on the trigger bow and create a new blueprint class. I'm gonna call this guy dead zone. Okay, for dead zone, it's gonna be used for both the wall and then the snake tail, because they have the same functionality basically. I'm gonna go open that though, and then I don't have to change anything other than maybe let's just have it for now, right? And then I can right click here and create a new blueprint, new child, and call this guy tail, snake tail maybe. Okay, so dead zone is going to be whoever, when the head overlaps with any dead zone, it's going to be dead, basically. I probably don't even need to create a child class. This will be able to be responsible for both the wall and the snake tail. But, we can have some fun with class inheriting. So here in the snake head, I can then create another function called add tail. So custom event add tail, right? And this will add a tail to us. Okay, So I'm gonna go ahead and spawn a actor first. Actor from a class, and the class will be the snake tail. Okay. Now spawn transform, I want to put it one step behind the head. Right, so I need to know where that is. Let me go get actor location. Right, and then we use that to minus the move direction times step size, and that goes to there, and that goes to the spawn translation. I'm going to right click and split that and spawn it here. So this will spawn our tail one step behind the head. Okay, so before we do more, maybe we can try this. So we can go back here to the fruit. After add score, we can also ask the player to add tail, right? Okay, let's compile and save that. Now back here to the gameplay. Now if I do that, you can see now I'm having one thing behind me every time when I overlap upwards. The problem is it's just behind, it's not following us. And also we can refactor our stuff. We're calling all those functions here. That wouldn't be ideal. The better way of doing this will be here. We can create a new custom event in the snake head and call this eat fruit. Right? And then the eat fruit will call add score, and it's going to call add tail, because that's what its fruit will do, right? Two things: add score, add tail. And then here, what I would need to do, go back to the fruit, is I don't need to worry about anything, but rather just call eat fruit. Now, what happens after eating fruit will be taken care of by the player, right? That's how you should structure your system, right? Object-oriented programming, right? Whatever the player eat the fruit will up to the player, right? Not to the fruit to deal with. And then the fruit, all the fruit has to do after that is just destroy self, right? Destroy actor. Destroy actor. Where is it? Destroy. I keep finding it hard to find it. Destroy actor here. Okay, compile and save that. That way the fruit is done, right? We don't have to worry about it anymore. You can see when I eat the fruit is gone. Okay, now back to the snake. Now, of course, I need the tail to be a different mesh. I don't want it to be the same mesh as before. So let me go ahead and get the mesh from the head. Get static mesh, and then we can set static mesh here. The spawning will be always spawn, so here, ignore collisions. Right, we're setting the mesh of this tail to be the same mesh as our head. Right, that way we're using the same mesh. I also want it to be smaller. Right, so the spawn transform scale can be something smaller, like 0.6. That way I can avoid instant overlapping also, right? Because they could be touching each other. Okay, so let's just take a look at that. Now you can see we have a smaller sphere behind. Okay, now going from there, then I kind of wanted to store all my tails, so I need a new variable. And so of the type, it's gonna be called tails, and the type will be snake tail. Object reference, but it's gonna be an array of object reference, which means a container that contains multiple ones. I'm gonna drag it from here and then append or add. I think add, yeah, add is the option here, the operation here. We're gonna add the new tail generated to the tails. Okay, again, after that you can double click on the line to add new reroute node to avoid clipping into each other. This is what's bothering me a lot on blueprint coding. It's like, why am I keep dragging those nodes all the time just to make it look clean? Okay, add tail, right? I'm adding those things. I'm spawning, set mesh, make it 0.6 of the size, and then we add it to an array, right? And then after that, in the tick, what I want to do is I want to keep changing their locations to pass the previous location, the previous tails location to the next one, and keep passing that along, right? So before we do these things, before we move it, right? We already set actor pre-move location, right? We can probably use that. Let me change that to previous location, previous atom location. Okay. All right. And then here, after that, I'm moving the actor itself forward, right? But I still remember the previous location. That's gonna be the location for the next tail, right? I'm gonna go for like a for loop for each loop, and the array we're gonna looping through will be our tail, the tails, right? So we're looping through the tails, and for every array elements, before we do anything, we're gonna get actor location first, because before we take the previous atom location, we kind of wanted to remember what this block is, and then we need that to be passed to the next one. So get actor location, and then we can promote that to a variable. Promote to variable, right? I'm gonna call this guy tail current location. We remember where this tail is before we move it, and then we move it, right? So I'm gonna go for add world offset, not rotation, offset. And the offset will be coming from the previous, not adding offset anymore. That's right, we're just setting the location because it's already memorized. Set actor location. And that's going to be setting it to be the previous atom location, right? The previous atom location for the first one will be the location of the head. And then moving on to the loop, we remember for every new atom, right? Every tile in the sequential order, we go from the first one, we store its current location first, and then we move it to be the previous one. And then we change the previous location to what it was before. So the next one will become what it was before move. So I'm gonna hold it down Alt and drag previous atom location to here. After the moving, I'm gonna change that to this. Okay. Right. So what happens is we will always transfer these ones to the next. Right, this one's location to the next, current location to the previous one now, and for the next one is to take that. Okay, and before you do that, you're also storing where it is before you move it. Otherwise, you lose that data. Right, so you have to store it, change the location, and pass the stored one for the next one to use. Okay, so compile and save that. Now let me drag a few more fruits so we can see what's going on. You can see now it's following me. Right, every time I eat a new fruit, I'm just gonna get longer. And because it's just basically transferring that over to the next one, they're always gonna be, following the next one by one. Okay. Now, another thing I want to do is, of course, to set up the arena. So I'm gonna delete all these things and then make it bigger here and bigger there. It's probably gonna be the size of the arena. Let me drag the camera up so we can see the whole thing. Not quite far enough. Maybe not that big, it's too big now, so smaller here. That would be fun. Yeah, I think this is about right. Okay, and then I need to set up the walls, so that's gonna be dead zone. I'm gonna drag the dead zone in here. Scale it. Right, that's gonna be the walls. Holding down Alt and drag it over here. Alt and drag. Negative 90 here. And then there. Right. So I wanted the fruit to be randomly placed somewhere in this arena. And that's going to be done by something we call the game mode. I'm going to right click here and say new blueprint class and then game mode base. I'm going to call this guy snake game mode. Okay, double click to open that. Event graph here. Now I need to know the size of this arena, right? That's the floor. So the easiest way to get it is just to tag it, right? So I'm gonna go here and then search for a tag, and then I'm gonna add a actor tag. Call this guy floor. Right. Now in the game mode, I need to find it in the begin play. I'm gonna say get. Oh, I'm gonna create a custom event. Call it spawn fruit. Okay, and then we're gonna get all actor of class with tag, and the class will be I think it's a static mesh, right? You can see static mesh actor. So static mesh actor, and tag will be floor. And we're gonna get the first one. We're gonna assume there is gonna be one, right? Otherwise the game will crash. But you know, we can do the safety check here, but let's just, you know, make it simple because we will always have the floor there anyways. Okay, maybe we can give them warning just to be more professional, but you know, we don't have all the time to do too detailed stuff. Okay, so we're gonna get the first one, which should be the floor, right? And then we can get bounds, get actor bounds. Okay, and then we have the extend and origin. I'm gonna split that and that. I only care about the Y and X, right? So origin and extend X, extend Y. So that's how far it is. Okay, let's see if I get actor. Get bound, get local bounds. Doesn't really help. Yeah, I think this is what I can get. Bounding box. Nope. Yeah, that's the only thing I can get. Yeah. Okay. So I know the origin, I know the extend X, I know how big it is, right? Extend is gonna be how big the X is. Okay. So here we can say the spawn area on the x-axis will be, I think the origin is going to be 0. Let's see. The floor is 0, 0, 0. We can assume that because those are 0. And probably just use the extend x, right? And then we can divide that by 2, right? That's how far away we'll be able to move, or we will be able to find on the positive and negative direction, right? And we can do the same thing for the y. Okay, and then we can get a random float from in range, right? The range mean will be multiply that by negative 0.8 because I don't want it to go all the way to the edge. Okay, or times positive 8.8. That's going to be how far I want it to be able to move, right? So min will be this one, max will be this one for the x. For the y, I'm going to do the same thing. So divide it by 2, and then we can get how much, how big this is, right? Extent will be the size, right? And then we kind of wanted to divide that by 2 to get the sizes, and then we time that by positive and negative 0.8 to reduce how far we can go. And this is going to be my x and y random location for me to spawn the fruit. Okay, and then I'm going to do a spawn actor from class, and this is going to be the fruit class. And the class spawn transform, I'm going to split that and split that. Okay, so this is going to be the x, and this is going to be the y. Right, and then the z, let's see. If I drag one in, z will be like 180 or something. I think that would be proper. This is our snake hat, so maybe it's something like that. 120 should be fun. So I'm going to change that z to 120. Okay. And that goes all the way to there. That way it's going to be spawning based on the floor. Right? And of course we want to do that in the first begin play, so I'm going to do that. Spawn fruit. Okay, let's take a look. Oh, not seeing that because we're now using this guy. So let's go to the project settings, map modes, and I want to change our default game mode to our snake game mode. It's probably better to also save the scene and call it game. Right. Anyway, let's go ahead and play this. Now you can see we have a, we have one of the fruits spawned. Now whenever we eat a new fruit, before we destroy the fruit, we can also get game mode and then cast to fruit game mode, snake game mode, and then we spawn another fruit here, and then we destroy this fruit. Play this again. You can see now we're spawning a new fruit. Right, it's down there now. Another one. Yeah, you can see this keeps going now endlessly. You can see our score is also updating. Right, we're almost there. Right, it's basically all the core mechanic is there. I think it's not. Maybe I shouldn't be dividing that by 2. I don't see this is getting created further enough to the edge for some reason. Oh, come on. Almost dead. So I guess I actually did that wrong here in the game mode. Let's go there. So I shouldn't be dividing by 2, I think. I can just use the x and y. Okay, so I'm gonna put it in here. Just in case I need to go back, but yeah. Now it's in a further away place. Shouldn't be going too far anyways. Alrighty. So next step will be the dying mechanic, right? We wanted to, when we overlap with the head or overlap with the box here, we should be dead instead of going through. So I'm gonna go to the dead zone here, right? And then I can say, I can go override the player overlapped, right? We can tell the player to be game over. So I probably need to just ask the game mode to do that. Okay. So I'm gonna go create another blueprint class. Oh, another widget blueprint. You have seen this before, right? Just another widget blueprint. Call this guy game over. WBP game over. Okay, and then we'll add this thing also to the viewport. Okay, so for here, I'm gonna go add a text. Control Shift and click on the center, and then sets to content, and this is gonna be saying game over, right? And then here size can be bigger, 50. Maybe we can move it up by dragging the Y, and then we can add two buttons, a button here, and then we can anchor to the center, and then we change it on the X direction. Okay, sets to content. We can then drag in a text to the button, and the text will be saying restart, right? And then I'm gonna grab the button, rename it to restart button, and I believe I can grab this guy and press Ctrl W to have a copy, and rename that to quit, and that's gonna move to the other side, and the text will be changed to quit. Maybe I shouldn't be set to content because that's gonna make them different. Can I have a field space? Can probably do that. I need more space in there. Not ideal. I probably need to just define the size myself. Yeah. Okay, I have two buttons. Game over, right? In the graph, I'm gonna go grab the quit button and then unclicked. Quick button, I'm gonna just run console command. You know, yeah, run or console command, execute console command, and the console command will be exit. Just to keep things simple, but there could be an easier approach than it's quit game or something. You know, and then for the restart button, unclicked. This may not be the best solution though, because you wanted to disable the console command when you're actually releasing the game. Yeah, maybe I can just search for quit game. Yeah, there is a quit game. Yeah, I got used to that. Let me delete that. That's just not the right way to do it. Okay, quit game, specify player, get player controller. Quit preference is quit, ignore platform restrictions. Yeah, I don't need to care about that. Unclicked will be restart the button. Restart button unclick will be restarting the game. So there's going to be load level or open level, and level will be game. Right. So that's what's happening here. Right, so in the game mode, we can create the game over. Game mode will be in charge of all those game over stuff, right? So I'm gonna create a custom event, let's call it game over. Okay, and the game over will first of all create widget. The widget will be game over widget. Right, only player will be get the first player, get player pong. Now get player controller, actually. That's going to be the player controller. Right, and return value will be then add to viewport. Add to viewport. And also, I wanted to change the player from doing any other movements. Right, so I probably need to just pause the game. Set game paused to paused, right? And also want to set set UI, set input game UI only. Right, player controller again will be this player controller. widget to focus will be this widget we created. Now to make it work though, we may need to make the widget focusable. That should be just a flip here. So game over. Class settings is, or class defaults is focusable. Check that out. Right back here to the game mode. Yeah, we can also show mouse cursor. That's going to be from the player controller. Set show mouse cursor to be showing. Save that. Okay. Now when we hit any dead zone, we just get game mode, and then cast to snake game mode, and then we call game over. Okay, so now the game over will take care of the game over stuff. Let's see if that works. So go ahead and play this, and oh, let me just hit that wall right away. You can see now this game over pops up, and we can hit restart. But you can see we're still having the UI locked. So probably need to fix that by going to the WPP game over. So when we restart the game, of course, after opening the level, we can set game mode, set input mode, game only, yeah. And then we get player controller, and then we show mouse cursor to not show the mouse cursor when we restart. Try this again, right? And make the UI bigger. I eat the fruit, gets longer, keep eating. Yeah, let's try hit this the tail this time. Oh, restart. Oh, I still cannot do the input for some reason. Oh, so in the WP game over, I need to set the player controller, of course. So that has to go there also. Because you could have multiple players, so you need to specify which player you're talking about. Okay, let me grow longer so I have a bigger tail to collide with. Right, let me try that. Yeah, I hit myself. You can see I'm also popping up game over. That's all because the snake tail is also a child of this dead zone class. Same goes for the walls. Let's restart. Yeah, this time I can start playing right away. Right, all mechanic is in there. Alright. Cool, that's gonna be the full snake game, right? There's nothing else than that we need to do. If you want to be strict, some of the snake game allows you to go over the wall to the other side. That can be something you can implement also, but you really then have to specify the, where's the edge, and you want to create like a whole grade to take care of that. Okay. Now we're doing this in Unreal Engine, but all those things is transferable to all other engines. You can even just write it with printing. I think there's a there is a way you can use just raw coding with C++ or C#. You print out the snake using hashtags or stuff, and you can get it work that way too, right? But now with the game engine, the job will be easier for the visual, and but it's also using just very similar algorithm. In this case, the core algorithm for this is to determine. I think the hardest part is to determine where is the tail. How does the tail follow? Right. It's gonna take some thinking to achieve. Oh, come on. I'm still alive. Right? Yeah. So that's gonna be the whole process of creating a snake game. As you can see, It is pretty, well, it's not easy, but I think it's easy on some level. I'm trying to simplify a lot of stuff, but it does introduce the whole structure of a game, right? If we can make it better, I don't need to place this thing here. I can delete that. That's going to be the player start. I'll drag it here. Yeah. That's fine. My bow is not that high. And then you want to actually specify the player by going to the snake game mode. And then you go to the class settings, class defaults. The default pawn class will be snake head. That way we don't even have to place one. It's going to create one there in the center, which will make the game more robust. Okay. There's one arrow, hidden arrow that I didn't do. So what if you don't have this? If you don't have the floor, let me save everything. If you don't have the floor and you play, you can see I got an arrow here because it doesn't know where to, it doesn't find this floor in here. So it's probably better to print out a proper warning for that, for the level designer to make sure that to label the floor as the floor, right? By doing a tag. But if we're the sole designer and this is just one level and it's already done, I don't think it's necessary, but something you may forget in the future and you don't know what's going on there, right? Because you could easily forget those things when after a while. That's just some hidden non-professional part of the game development, other than trying to make it all fitting into the structure of the game, right? So we don't really put things in the wrong place. The game mode will take care of the game mode, right? To spawn fruit and to take care of the game over, right? And then other things are done by object-oriented programming. So the head will take care of its own snake tail stuff, right? It's taking care of its own score, add tail, and eat fruit, right? And just input control, and then we can play basic setup, like adding the UI and stuff. All right, that's it for this video. Thanks for watching. See you next time.